the equation as original, and we have the result equation. Want to see what happens in between? Shh, girls. Want to see what happens in between. So, well, the way I use to do this is I need to have like the rule only on one side, and all the coefficient, all the adding and subtraction needs to move to the other side to combine with the y. Okay, so for example 2, we can see we have two equations. The original one is y equals to 2 root 4 minus x and plus 3. And then the new equation is y dash equals to minus x dash plus 6. So first of all, I need to distinguish them by the dash. So new is dash and the old one is just xy. The next thing is this not looks right. Okay, it not looks good. I want only square root. I want two equations have exactly same format. So I just want the square root to sit on one side. Okay, this is the only thing can sit on right hand side. So everything else needs to move to the left hand side. So what we should do is, for that one is y minus 3 over 2 equals to square root 4 minus x. And on this side is y dash minus 6 over negative 1 equals to square root x dash. Okay, so this equation goes to that one. So that's what we have. Okay, that's what we have. Because we want to find the connection between x and x dash, y and y dash, that's the only way we can equalize them. So left hand side weight the same and right hand side weight the same, and they're all in the rule square root. What we should do is y minus 3 over 2 equals to y dash minus 6 over minus 1. That's for the y side. For the x side, I don't need to include the square root. I just have 4 minus x equals to x dash. Okay, everything needs to be rearranged. Okay, everything needs to be rearranged. Well, x side is easy to rearrange. For the x, we have x dash equals to minus x plus 4. I want to have DRT order. Then this equation must be in the expansion form. Okay, must be in the expansion form. This is the expansion form. No bracket, which is good. It will be in the DRT form, DRT order. So this is the x side. And I also see the new y equals to what? Okay, if we see the new y, okay, what I will do is 2y dash minus 12 equals to minus y plus 3. And then you plus 12 on both sides, we have a plus 15. And then you divide 2 on both sides, y dash equals to negative a half y plus 15 over 2. Okay, expand form. I don't want to write over 2. I don't want to write like in the bracket y plus 15. That's the form I want to have. Expansion form, which can give me the DRT order. So now we can talk about the transformation. So if we talk about dilation, a half is the dilation. Dilation by a factor of a half. Well, I'm not going to write full sentence, not enough space. Dilation by a factor of half from the x-axis. Okay, that's the only dilation I can see. And reflection. Because you have negative and negative. Reflect in the x-axis and y-axis. Okay, you have two negatives, so it will be reflect in the x-axis and also reflect in the y-axis. And number 3 is the translation. Well, you move to the right. Okay, translate, fold to the right, and 15 over 2 up. Okay, 15 over 2 up. Okay, the order can't change. If you change the order, the number will change at the same time. Okay, if you change the order, the number will change at the same time. So it will be different. Okay, so dilation by a half from the x-axis, reflect in the x, reflect in the y, and then move to the right by 4 units and move up by 15/2 units. Okay, so that's the way the preferred way we like to describe it. Alright, I think most of you already get it yesterday. Just do a little bit like clear, make it a little bit clear. Let's look at example 4 first. Question? Well, or you can talk about, well, for this question, you can talk about x first and then talk about y. That's alright as well. So what happens to the horizontal and what happens to the vertical not going to influence each other. For example, you can talk about x first. This is a reflection in the y-axis and then translate 4 units to the right. And then dilation by a factor of a half from the x-axis and then reflect in the x-axis, then move up by 15/2 units. So you can either talk about like all the dilation first, all the reflection, and then all the translation. Or you can talk about the x dilation, reflection, and translation, then y dilation, reflection, and translation. So you can talk about separately as well. So both ways acceptable. Okay? Yes? No, like it's not going to influence each other. For example, the dilation from the x-axis is changing y, and this is not going to affect the horizontal movement. So that number won't change, so it doesn't really matter. You can just write 1, 2, 3, 4. Any other questions? Okay, if no, let's go to example 4 first and then back to 3. So for example 4, okay, same type. Find the sequence of transformation which takes the graph y equals to fx to the graph y equals to 3f1 minus x minus 2. Okay, in this question, y equals to fx is the original one. Y dash equals to 3f bracket 1 minus x dash minus 2 is the new one. Okay, distinguish between old one and new one. So this one is not like a square root or square or cubic or cube root. Like it's not really something given, but it's even easier. The fx itself is the rule. Okay, the fx itself is the rule. It represents some rule. I don't know what rule, but it represents something. And then you put things in the bracket. So the only thing can leave on the right hand side is this and this for both equations. F bracket. So it's same as you insert something into square root, you insert something into cube root, you insert something into square. So this is the only thing we can give on the right hand side. So, well, the original equation is good enough. Okay, the original equation is good enough. The after equation, we need to change that. That will be changed into y dash plus 2 over 3. Okay, we need to make it into that form. We only leave the rule on one side, so which is fx. Okay, so this one still stay the same. Now we can equalize both sides. Okay, we can equalize. Well, you don't need to equalize the f. You need to equalize the thing you insert. Okay, you input. So this one will give me y dash equals to 3y minus 2. This one gives me x dash equals to minus x plus 1. Okay. Then we talk about the dilation, reflection, and translation. So dilation. Dilate by a factor of 3 from the x-axis. Reflect in the y-axis. translate 1 unit to the right and 2 units down. Okay, it follows DRT order. It's in the expansion form. How do you calculate the equation? Times first and then minus. So it's dilation first and then translation. Negative first and then add 1. Reflection first and then translation. So it follows the DRT order here. Okay, when it is in fx, it's even easier. Okay, I really like questions with fx because you know it's the f bracket on one side, everything else to the other side. Okay, so that's this question here. Alright, the next one will be harder, okay? So we focus on the next one here. I don't have enough space. You need to find a separate page, okay? You need a separate paper to do this question. The last page, maybe? Do you have empty last page? It's not that hard to find some paper, okay? Alright, everyone. Let's have a look at this question. It's a hard question because at the beginning, okay, the form is not good. Okay, the format is not good enough. I'll tell you why it's not good enough. Second, I changed the question a little bit. I make sure like you want dilation from the x-axis and dilation from the y-axis. I give you a dilation direction. So that makes the question even harder. So first, let's think about this. What's the difference between this question and the other question you did on this page? Well, yes, square. How many x do you have? Can you deal with this with 2x? I mean, just use that form. Can you do that? We have 2x in this equation. Well, if you look at them separately, for x squared, okay, you have 3x squared and 4x squared. For x, you have minus 6 and 4x. Like, you can't compare them. Like, there's no patterns between them. And they're not having the same dilation. So we can't do transformation questions when there involve 2x in one equation. Okay? So there are 2x, I can't see what's happening. And I can't recognize the rule. So what's the formula? Yeah? Well, yeah, I'm just talking about the general form, why it's not working. I just said why it's not working. If you just have like 2x, it's not going to work. Like, I can't compare them. So I must make them into the same format, and then I can compare. Okay, so turning point form will be the form like I should use, because only one x and one y will be involved in the turning point form. Okay, ax minus h squared plus k. That will be the right form. So first thing we need to complete the square. Okay, first thing we need to complete the square. So let's do that first. Okay, let's do that first. Give you 1 minute to complete the square. Just do your own way. You should be able to figure out what's the turning point. Okay, after you finish, you check your answer here. No, you don't need to see my working. I just want you to check your answer. Which one I don't get? First one or the second one? Okay, I need to move on. I can't finish otherwise. If you can't get it yet, just copy this down. Okay, just copy this down and you figure out that later by yourself. If I have some time left. Okay, that's the two equations you get in the end. What do you think you will leave on the right hand side and what do you think needs to move to the other side? Yep, it's only the thing in the bracket with the square needs to be on one side. The rule is something squared. Okay, the rule is something squared. So what we need to move is y plus 2 over 3 equals to x minus 1 squared. Okay, that is y dash plus 1 over 4 equals to x dash plus a half squared. So we equalize both sides now. Okay, you don't need to include the square because the square is the rule. Okay, something squared is the rule. So you just put the thing under the square. So it's x dash plus a half equals to x minus 1. And as you know, we need to rearrange it to make x dash and y dash to be the subject. Well, it needs to be clear on what needs to be the subject. Why x dash needs to be the subject? Because x dash equals to some x, some old x doing what? Okay, 2 lots of the old x plus 1. So it's actually talking about the transformation. So the new point is old point stretched by 2 times and then move right by 1 unit. So that's why we need x dash and y dash to be the subject. Okay, this one I can cross multiply, which I feel is easier. So 3y dash is 4y plus 5. Y dash is 4 over 3y plus 5 over 3. Okay, DRT order. Dilation by a factor of 4 over 3 from the x-axis. No reflection. Translate 3 over 2 units to the left. And 5 over 3 units up. So there's no reflection, so it's only dilation and translation. Can you see we answer part A now? Okay, we answer part A, like the part A I give you. Okay, dilation by a factor of 4/3 from the x-axis and translation by how many units? You just finish that. We translate 3/2 to the left and 5/3 up. That's for A. Okay, that's for A. Let's have a look at B. A is very easy, okay? A is very easy because A is very straightforward. You just rearrange as you can and then equalize both sides and find x dash y dash. It's easy. But let's think about B. Okay, A is like, oh, I want to do this and follow my logic, I get this answer. So that's why I said it's easy. But for B, B said it's a dilation by effect of what? From the y-axis. Can you see in my solution here, there's no dilation from the y-axis at all. Yes, it's only dilation from the x-axis. Okay, can you let me know which number is actually give the dilation? Like, let's go back to this. I will just do that again. So y equals to 3x minus 1 squared minus 2 and y dash equals to 4x dash plus a half squared minus 1. Is that minus? Yeah, it's minus 1. Okay. Okay, which number in both equation or like in each equation, which number actually give you the dilation? 3 and 4, right? Because we move the 3 to left hand side, we move the 4 to left hand side. That's why the dilation happens from the x-axis. Like if there's a stretch in the y direction. I don't want dilation from x-axis, which means I don't want to change the stretch in the y direction, which means I can't move the 3 and 4 to the other side. Okay, in this case, I can't move the 3 and 4 to the other side because if I move it, it will give me a stretch. Okay, it will give me a stretch. So I don't want this. So what I will do is, well, the 2 can still go the other side. Okay, the y dash plus 1 can still go to the other side. That's the translation. Okay, that's only the translation. But I can't just get the 4 by itself stay there. Okay, it's not satisfy what I want. Therefore, this 4 and 3 must go to combine together in the bracket, which means this 4 needs to walk into the bracket. Okay, this 4 needs to go inside. How this 4 can go inside? Sorry? No, it can't expand. You need to still maintain this square. And this 4 needs to go inside. Multiply? I can't directly multiply 4 inside. I can multiply, but multiply by what? 2. 4 is 2 squared times x dash plus a half squared. A squared times b squared is what? Is ab squared, right? A squared times by b squared is a times b, bracket squared, exponential law, okay? So this one is y dash plus 1 equals to 2x dash plus 1 squared. So what you should do to the 3? Square root. So square root 3 squared times x minus 1 squared. So what we have is y plus 2 equals to root 3x minus root 3 and then squared. Can you see the dilation disappeared on y side? Like why there's no dilation happen at all? It's only a plus and minus. So what we have is y plus 2 equals to y dash plus 1 and root 3x minus root 3 equals to 2x dash plus 1. So y side is easy. Y dash equals to y plus 1. And let's think about the x side. 2x dash equals to root 3x minus root 3 minus 1. Okay, it can be a minus root 3 plus 1. Okay, so minus root 3 plus 1. You bracket that. So minus root 3 minus 1, you can say it's the minus the sum of it. Then x dash equals to root 3 over 2x minus root 3 plus 1 over 2. What's root 3 approximately? 1.7. Okay, you need to remember 1.7. What's root 2? 1.414. Okay, so root 5? I think it's 2.3 something. Okay, I think it's approximately that 2.3 to 2.4 in that range. Okay, so you need to remember approximation value. So root 3 is a 1.732 plus 1, 2.7 something, and divide by 2 is still 1 point something. Okay, this is still 1 point something. Okay, what's the dilation reflection we can talk about in this question now? So what I can say is dilation by a factor of root 3 over 2 from the y-axis translate root 3 plus 1 over 2 units to the right. No, to the left. Minus to the left. And 1 unit up. Can you see the translation unit change as well? Like how many units that change as well? The dilation factor change as well because it's dilate from the other axis. This is the answer for part B. Y plus 1. Any questions? Any question to this one? Yeah? Yes? Yeah?
Like this. Why is it going to be divided by 1, 2,
Yeah. Okay, so what's the difference between the question between A and B? So for A, only dilation happened from the x-axis, which is changing y value, right? And B, the question asks you is the dilation only happened to the x-axis, which is only y-axis, only changing the x value. Well, this question is that, well, it's more like a multiple choice question. In the multiple choice question, the question will be set. Will give you this is this equation to this equation is the dilation by a factor of what from a particular axis. Okay, it's not going to ask you to do whatever you like. So this question is give you why, like in multiple choice, like what you need to do. So for part A, okay, I'm not sure if this 100% answer what you mean, but like for part A, because this is the dilation from the x-axis, which is changing y value, so all the coefficient needs to go for the y side, and in the x I want the pure x and x dash. I can make sure there's no dilation at all, it's only transformation happen. And then for part B, I need a dilation from the y-axis, which is changing the x value. So the coefficient can't go to the y side. If you go to the y side, there must be a dilation for y. So that's why I combine that within the bracket to make it only happen, dilation only happen for x. So that's why I'm trying to do the working out for A and B. Does that make sense?
If the question was translate,
Yeah. There's no questions really focused on translation, which direction, because translation will change according to your dilation. If your dilation change, you reflect that the translation will change. But like if it's only, for example, x squared and x squared plus 1, the translation can't change, it's only move up by 1 unit. Sometimes translation can't change, but reflection and dilation will change. Any other questions? No? Okay. I'll stop the recording then.